Hello guys, this is your length and area lab. So for those of you that missed it or need a little extra help, we're going to run through this real quick. Starting at the top, the fundamental metric unit of length is the meter. And this is a meter stick, so of course it's a meter long. It's about the length of a yard. Okay, they're kind of comparable. Then we use prefixes to modify measurements. Today we're talking about them in terms of meter. But I want you to be aware that you can use them in terms of mass, you can use them in terms of volume, you can use these prefixes with everything in the metric system. So it's not just isolated to the measurement of length, the meter, even though that's how we're using it today. So the first one is deci. Deci means 1/10. And when we say decimeter, that means it is 1/10 of a meter. In other words, this is a meter stick. There are 10 decimeters in 1 meter. And a decimeter is about the width of my hand. That's just a good reference point. The next one we're going to talk about is centimeter. Centi means 1/100th. And so here's a meter, there's a decimeter, and if you look here, there's 100 of these along this meter stick. And a centimeter is about the width of my pinky finger. Some of you guys with little fingers, it may be more along the line of your index finger or something like that. And the last one we're going to talk about as far as getting smaller is the millimeter. The millimeter means 1/1000th, and that is small. There is 1,000 of those things over the length of this meter, and that's right here. I compare that to the width of the lead in my pencil, or the tip of my ballpoint pen. Getting a little larger, we're going to talk about kilo. Kilo means 1,000. So when I say kilometer, then that means 1,000 of these meters put together. Miss Jenkins and I asked them to buy 1,000 of these meter sticks and put them end to end so you could see, but the school wouldn't put it in our budget, so we didn't get to do that. But you'll just have to imagine what that's like. Okay, so now we get down and we're going to do some exercises. The first thing and the most important thing is you have to estimate to the nearest one spot. Okay, so whatever measuring tool you're using, you're going to estimate one spot beyond that. For example, I'm going to measure this poster board, and I have to do it in meters. So I'm just using this big meter stick here. I know we could be more accurate if we flipped it over, but we're not going to do that. So when I hold this up here for length and I measure it, I'm going to guess that is about 0.5 meters. Okay, I'm guessing that's about 0.5 meters. And then when I go to measure the width, I hold it up here and I look at it. I'm going to guess that is about 0.3 meters. So again, I could flip it over, I could be more accurate, but we're not going to do that. Now, let's go on to the calculations. The big part of this is conversion, okay? And we're going to use this railroad method. Miss Maurer calls it the football method. But that's what this lab's really about learning, because as we get later in chemistry, you're going to use this more and more and more. So, to start off with, we're going from meters to decimeters, and this is under length conversions on your worksheet. So, I'm going to come right here at the board, and if I write down what I started with, you always write down what you start with in the top left. So for my length, I started with 0.5 meters, and I make my little railroad tracks, and I have to know the conversion. Well, we just talked about it. And there are 10 decimeters for every meter. Okay, so in other words, 10 decimeters equals 1 meter. Well, I like to think about it in math terms. So I can write that 2 different ways. I can write 10 decimeters over 1 meter. And since they're both equal, it should be equal to 1. Any number divided by itself equals 1. So 8 divided by 8 is 1. 12 divided by 12 is 1. So as long as they're equal, I can write it that way. Or I could flip it over and write it this way. It's just a matter of which one benefits me better at the time. And you'll see what I mean here in just a second. So both of these are equal to 1. When I'm doing my conversion, I'm trying not to change numbers. So when I multiply this by 1, I'm changing the units it's in, but I'm not changing the number itself. Let me show you what I mean. Oh, I love when that works. So we said we could write this either way. I'm trying to get rid of my meters and put it in terms of decimeters. So the way I'm going to do it is I'm going to put the 1 meter down here, 10 decimeters up on the top. That way my meters are opposite of each other and they will cancel out. I'll be left then with the decimeters, and that's what I wanted my answer in to start with. So 0.5 times 10 would equal 5 decimeters. Okay, let's go to the next one. The next one wants us to convert meters to centimeters. So I always start with what I know, and I know I have 0.5 meters. That's what I'm going to start with. Well, I look up at the top, and centi means 1/100th. So there is 100 centimeters in a meter. Again, I can put either one of those terms on top. But I want to get rid of meters, so to get rid of it, I have to put the meters on bottom. So 1 meter is equal to 100 centimeters. So again, that way meters cancels out, because they're across from each other, up and down, and I'm left with centimeters. 0.5 times 100, move the decimal 2 spots, will give me 50 centimeters. Okay, so that's all I'm going to do for the top. Let me move on to the second part here. So the next thing I'm going to do is I'm going to go all the way down to number 2, and this time I'm going to measure a card, but I'm going to measure it in centimeters. So let me flip over to the centimeter part of my meter stick, and I'm going to measure it here. So my length of this card, is just over 15, but remember we have to estimate 1 spot. So a lot of my students put 15 centimeters. You can't do that. When you send that number out, people assume the last one is an estimate. So they would think that the 5 was an estimate, and the only one you knew for sure was the 1 in the 10 spot. You always need to estimate 1. So in this case, it's a hair bigger than 15, so I'm going to call it 15.2 centimeters. If it looks like it's exactly on the line, then you need to say it's 15.0 centimeters. But you always have to have one that is an estimate beyond what your tool will demonstrate. So I'm going to put 15.2 centimeters. When I measure the width, I am going to get 10.2 centimeters. Okay, so I'm going to write those down, and I'm going to go back and I'm going to do my conversions again. So up at the board, I always start with what I know. And this is under length, so I know it was 15.2 centimeters. Well, it wants me to go from centimeters to millimeters. In my head, I know there are 10 millimeters for every centimeter. So if you know that and understand that, you can do the conversion right here. 1 centimeter equals 10 millimeters, multiplied by 10, and be done. Matter of fact, I'll go ahead and do that real quick. So 1 centimeter has 10 millimeters in it, right? Centimeter cancels, so I'm multiplying 15.2 times 10, and that will give me 152 millimeters. A lot of my students have trouble going to anything other than the base unit. This is probably the easier way. This is the way I showed them. What I would do is I would start with my centimeters. Start with what you know, 15.2 centimeters. Well, I would take these centimeters to meters, because we know that. We did that at the top. So we know 100 centimeters makes 1 meter. So I cancel that out, but now my answer would be in meters. We don't want the answer in meters, we want it in millimeters. So I'm going to do one more step. I'm going to go 1 meter, they're opposite of each other, is equal to 1,000 millimeters. Okay, that might make a little more sense for you. So meters cancels out, and I'm left with millimeters, and that's the unit I wanted to end in. So I'm going to go 15.2, and we multiply by everything in the top row, and then we come back and we divide by everything in the bottom row. So 15.2 times 1,000, so I'm going to move the decimal over 3 spots, and then I'm going to divide by 100. And that would give me 152 millimeters, excuse me. So if I look, I got the same answer. Okay? Two different ways to do the same thing. But if you're unsure how many you have to move or multiply by for your direct conversion, you can always go through the base units. I'm going to go ahead and do one more of those because I know that can be kind of tricky. So I'm going to do the centimeters to decimeter conversion now. Again, I always start with what I know. And I know I have 15.2 centimeters. So, centimeters to meters. I know there are 100 centimeters in 1 meter. Centimeters cancel. I've got it to meters now, but according to my paper, I'm trying to get to decimeters. So, I'm going to do one more step. There are 10 decimeters in every 1 meter. Meters cancel, and I'm left with decimeters, which is where I was trying to get. 15.2 times 10 is 152. Divided by 100 is 1.52 decimeters. Okay, so that's the answer to B at the bottom portion. Now, we're going to go ahead and flip over to the back real quick. And now, instead of talking about length, we're going to talk about area. A lot of mistakes made here. I'm going to go relatively quick and I want to show you some of the pitfalls. When we talk about area, we're talking about a derived unit. In other words, we're going to talk about two lengths multiplied together in this case. Okay, two fundamental units multiplied together, and that makes the derived unit. Now, our base unit is going to be meters squared because our base unit of length was meters. I multiply length times width, I get an area, meters squared. Some other metric areas of unit could be decimeters squared, they could be centimeters squared, they could be millimeters squared. If we're talking about a great big area, it could even be kilometers squared. So any of those things could be metric units. So let's go ahead and look at how we find the area of that poster board. So I'm going to go back to my smartboard here. Probably should have just stayed there. But the area of the poster board, I'm going to take the length and multiply it by the width. So if you remember, the length was 0.5 meters. And the width I found was 0.3 meters. Well, if I multiply those together, I get 0.15. And since I'm multiplying meters times meters, it is meters squared. Very important that you write the proper units. Now, I have to convert that over to millimeters squared. And man, a lot of people have trouble with that. Let's write up here what it should be. 0.15 meters squared. A lot of people have trouble with that. And here's the main thing they do. Didn't like me that time. Here's the main thing they do wrong. They tend to take that and they multiply it by their one conversion. So in other words, they go like this. They go, start with what we know. They go 0.15 meters squared. And they go, well, I know there are 1,000 millimeters per meter. So they go 1,000 millimeters per meter. And they multiply that out. And they get the wrong answer. Here's why they get the wrong answer. I did not cross out meters squared. I only crossed out meters. And now I've just got meters times millimeters left. So you can't do that. Okay? When you do this conversion, you have to be able to cancel out fully. So if I've got meters squared, here's what I'm going to do. That gets rid of one of the meters, but I have to do this one more time. So 1,000 millimeters times 1 meter. So now I've got meters squared down here and meters squared up here, so they're both gone. And if I multiply it, I'm left with millimeters times millimeters or millimeters squared, which is the unit I want to end in. So this looks really promising. So times 1,000, I'm going to go 1, 2, 3, and I get 150. Times another 1,000, I'm going to put it 3 more spots. So I'm going to have 150,000 millimeters squared. Okay, and the last one I'm going to do here, I'm going to help you out one more time. And then Ms. Jenkins and I are going to cut you loose and you're going to be on your own. You need to be aware that the conversion for feet to meters that I gave my students is 1 foot equals 0.3048 meters. Okay? And we're going to convert the area of the poster board into feet squared. So, I'm going to start with what I know, 0.15 meters squared. Excuse me, it's an area, so it's squared. And I'm going to use my conversion. Now, I got to think, do I want my 1 foot up top, or do I want my meters up top? Well, I'm trying to get rid of meters, so I want it opposite. So I'm going to say 0.3048 meters. And that's equal to 1 foot. Well, if I stop there, I've got meters squared divided by meters. That doesn't get rid of it. And I'm not in the units of foot squared. So I'm going to do the same thing again. I'm going to say 1 foot. And I'm going to say 0.3048 meters. So now I've got meters times meters, or meters squared, under meters squared. So those are canceled out. I've got feet times feet, so my units are going to be in foot squared. So that actually works out. And then what I'm going to do is I'm going to take my point, so I'm going to take my 0.15 and I'm going to divide it by 0.3048. Now, some people just hit divide by again, and that seems to mess up a lot of our calculators. So as soon as you do that first thing, go ahead and hit equals. Okay, so 0.15 divided by 0.3048 equals, and then go ahead and divide that answer by 0.3048 again, and that will give you your answer. I don't have it calculated, but that's easy enough to do. So those should be all of your steps to completing your lab. Good luck. If you have questions, ask the teachers. Thank you, guys.